Hi, please welcome to the part 11 of this video series. We will continue looking at the AWS Solution Architect Associate real exam questions. Please focus on the concepts explained for each and every option. The chances of same or similar questions coming in the exam is very high. Please subscribe to my channel. This channel is dedicated to help you clear the cloud certification exams. For questions 1 to 60, please refer parts 1 to 10 of this video series. Let's jump into the questions. Let's look at question 61. You may pause this video here to read this question carefully. I have marked the keywords as per my opinion. You can mark your keywords. So you have a web application running on EC2 instances behind an load balancer. They use Route 53 for DNS. The full form of DNS is Domain Name System. So you remember GoDaddy.com, there's a lot of ad on GoDaddy.com. So it's similar to that, but the only thing is based on the domain, the routing happens for Route 53. Now, what is the pain point here? You have to set up a backup website. Why you want to do that? So that if the primary website is down, the backup website can be connected. Okay. So if you see in your project as well, you always create a backup resource so that if suppose the team lead is on vacation or on sick leave, someone else can do his job or her job as well. So the same concept is required here. If the primary website is down, the backup website should be there, and there should be a message with the phone number and email address that the users can reach if the primary website is down. Now this solution has to be deployed. Out of these four options, which option sounds more correct? That is what we have to do. Now I'll start with option D. So what does option D suggest? So what it suggests is this entire application, no, you put in another region. Suppose this was in US, suppose East zone, you put it in another region somewhere in the west of US. And what you do is you use a server-side redirection on the primary website. So if someone is trying to access this application on the primary website, this is your primary website, right? And you have already created a similar setup in another region. Okay, so they are saying that you use server-side redirection. So what does server-side redirection do for you? Whenever people hit the primary website, it will redirect you to the this secondary website in the another region. But that is not our goal, right? Our goal is that to direct to a website where you can see whom to contact. We don't want automatic kind of transfer of the request from the primary website to the secondary website just because the primary website is down. So D will not work here. The second problem with D is, the thumb rule is whenever you get a question and whatever components are mentioned in the question. So if you see the components mentioned are elastic load balancer here, EC2 instances, and Route 53. So try to use all of these three and give a solution. Now here you are leaving Route 53 away in this option D. Okay, so that way also, like, that's a simple thumb rule that you should use for certification exams. First your attempt should be to use all of these components in the question, try to answer it. Now the second problem here is what you're trying to do is you are using another AWS region for this purpose. Okay, now this will be very costly actually. Why would you go into another region and set the same thing up when you can do a same thing in another AZ, like in the same region, another availability zone? You can do that and you can save your cost. So that's why D is also a very expensive operation. Now whenever you answer a question in an exam, you should always remember another thumb rule and go with the cheapest solution. Okay? The solution should work at a lower cost. That is the thumb rule. So D will not work at a lower cost. Second is D is not making use of all of these components. Route 53 is left out in D. Now option C, what it suggests is, it is saying you go to another region, so it is not cost effective. First point. Second point is telling you to use health checks of the load balancer for failover routing. So the failover need not happen at the load balancer level in this case. Okay, so what happens is how the load balancer works is you have this load balancer and it constantly does health checks. So suppose these are three EC2 instances, and the health of this EC2 instance, no, it goes bad. Now ALB will decide that okay, this EC2 instance health is bad. So whatever request it gets from the users of the website, it will always route to either this EC2 instance or this EC2 instance. It will not route to this EC2 instance. This is not failover. Okay, failover is this when this entire stuff is screwed up. Okay, and you have to go to an alternate mechanism. Failover, this EC2 going down and ALB routing to these two instances is not failover, and this is not a backup that the question is talking about. So we will rule out C. Two reasons: the solution is expensive because you are doing a AWS region. If you can travel by car, why are you asking Elon Musk to give you a rocket to travel? That's point number one. And point number two is this is totally out of context. ELB health checks is not used for failover routing. Okay. Now let's look at this option. So now if you see A and B, it is almost similar, except that you see here A uses failover routing and B uses latency routing. So what is latency routing used for? So take this example. Now you have same application in two regions. Okay, so now suppose this region is North America. Okay, and this another region is Europe. Now if you have users accessing this from Europe, you want to route to this region, the application in this region and not this region. That's where latency routing comes into play. Now if North American users are accessing it, it's wise to do a latency routing to North America regions. But in this question, if you see, it is about backup website. Whenever you see a backup website, it's a question of failover, because what was meant to work, it didn't work. Okay, that means your example, in a project your team lead is there and he was meant to work, and for some reasons he fell ill. Now he's not there for 3 days, so you want a backup website. Latency routing is like, you have, so you have two people, suppose, okay, and you think if there is a very solid work on, say, AWS glue, then A can do it, resource A can do it, and if there is a very solid work on uh, setting up infrastructure and EC2 instances, then resource B can do it. So now you will decide, if that kind of work comes, you will send it to A. If infrastructure work comes, you send it to B. So that is based on latency routing, like who can do it fast. So latency is like where I can provide the users, for example, Netflix. So if you are accessing from India, it is not, giving you that video content from USA. It has a region here in India and it routes you there. But if someone from Sweden is accessing it, it will route it via the European region. So that is latency routing. Netflix is a very good example. Amazon Prime is a very good example. So when we are trying to provide a cheap solution, so hosting it on S3, your backup website. So what is wise? Why it is wise? Because your backup website, if you see the content that you are displaying on the backup website, it's not the normal website content that you are putting on EC2 instances. It is a backup website which will only have a message which will say this is the phone number and this is the email address of the that the users can reach if the website is down. It's just a static website. It just gives a message: if the website is down, contact these people. Now, thumb rule, thumb rule, thumb rule. I repeat it thrice: thumb rule, because thumb rule says is, whenever you have a static website, put it on S3. That should be used for static website hosting. Whenever there is a dynamic website hosting, EC2 instances and other means can be explored. This is static website. Plus, why we use S3 is because for static websites, that's the cheapest, dirt cheap. You don't want to spend money. So every question, even if it is not talking about cost effectiveness here, you should always go for options which is dirt cheap, and it should work. So this will work. and Route 53 you are using because of, if the primary website goes down, it will do a failover routing. So we will set up a failover routing policy and the request will come to S3 website. So this is my final answer. Let's go to the next question. You may pause this video here if you want to read this carefully. Very small question. So please identify your keywords. So this is the question. You have your application here on S3. That's where we put usually static websites, and the end users, they are accessing this. Okay. Uh, and what's happening is that there is a lot of data. So it's a petabyte scale data. And if you keep transferring so much of data on and off, you are increasing your data transfer costs. So the question says you want to reduce your costs. So how to reduce the costs? So the first thing that comes to my mind is, what if I use cache? I plug a Cloud Frontier. So I can plug Cloud Frontier and it will do a lot of caching, and it will, so what will happen is the user makes that request. If the data is in cache, it will return it. If the data is not in cache, it will send to S3. So that way your data transfer cost will be reduced. So this is option A, and this is what I think is good, because this should serve the purpose. But let's look at other options. So it says you move it to EC2 and EBS. That will not help you resolve the petabyte scale outbound traffic. The traffic will still be there, and now the solution will be even more expensive because you are putting it on EC2 and EBS, which are expensive compared to the S3 solution that we already have. Okay. So B will not be cost effective. It will increase your cost. It will not decrease your cost. Question says reduce costs. That means you have to decrease the costs. Now let's look at this one. It says use a global accelerator and specify the existing website as a endpoint. So what is a global accelerator? See, what happens is when users try to access the content on S3, this is the website on S3, what will happen here is the routing will happen through internet. And if you want to fast track it, like reduce the increase the performance, then you can use this accelerator, because instead of always going through internet, it will use a combination of internet plus uh, Amazon's internal network, like between the clouds. For example, from Ohio to California, there is already a dedicated network that Amazon uses. So instead of going through the internet, you can use that route partially or fully to whatever possible extent to increase your performance. But then this is a performance enabler. This is not a means to reduce your costs. Plus, it will not reduce your data transfers. The data will be transferred the same petabyte scale. It will be transferred. So we will reject C as well because it is a costly option and it doesn't serve the purpose. So let's see option D. It's saying to re-architect the website to run a combination of API gateway and Lambda. Okay, so you suppose have a car, suppose Honda Civic, and then people are saying that you want to reduce the cost of the usage and etc., maintenance costs, etc. So what you do is you become very intelligent and you say, hey, why don't you buy a Mercedes? Okay, so D is similar to that. Instead of reducing the cost, you're saying, boss, throw whatever you have right now. So you have this, right? You have these users and S3. You throw this. You redesign the entire application. You use costly components. Instead of Honda components, you go to Mercedes. And then you increase your cost. So this will not suit. The question is clearly saying reduce the cost. This solution will increase the costs. So we will lock this answer and move forward. Let's look at the next question. So this question I've marked the keywords here. You can identify your own keywords. So you have an application. End users here will access this through the load balancer. Through the load balancer, the request will go to multiple EC2 instances here. And behind the EC2 instances, we have RDS database here. So now what you did is you did a beta testing. Okay, when you did a beta testing, what you found out is during reads this application goes slow. So when you are trying to read, the read will not happen from EC2, the read will not happen from load balancer balances the load, the read will not happen there. EC2 instances provide compute for your web applications. It will not read, this will not provide you read facilities. This reads from the RDS database. So the read, if something is problem, the problem can be resolved between RDS and EC2 if read is a problem. Okay, or it has to be something with RDS if read is a problem, because data is stored in RDS. So if the read is a problem, that means reading from RDS is a problem. Plus, the question also says that EC2 instances do not cross CPU utilization thresholds. That's do you know forensic science? Forensic science. Suppose someone dies and forensics come in and they try to analyze the dead body. So this is same like forensic. The performance is slow, and they try to understand. So they're saying that when the read is done, that time it's slow. The second forensic evidence that's saying is EC2 instance, it never crossed the CPU utilization thresholds. So that means there is no problem here. It never crossed the CPU utilization threshold. So what happens is, what is CPU utilization threshold? Suppose we just have EC2, one EC2, and you set the threshold as 70%. If the CPU is utilized to like 70% or 80% or 90%, the threshold is crossed. Okay, but here it is saying that none of the EC2 instances, the threshold never crossed 70%. Assuming 70 was the threshold, it was already operating at 30%, 40%, 50%. So then that is not a bottleneck, right? If the threshold values have been crossed, then there is a potential of a bottleneck there. But here it didn't cross, so that's not a bottleneck. So then how to address this? Let's see how to address this. So the first option says reduce the threshold for CPU utilization in auto scaling group. So what it says is, here you reduce the threshold. So suppose the threshold was 70% and the forensic evidence says it never crossed 70%. It was always at 30, 40, 50%. Now they are saying is you reduce the threshold. Instead of 70, make it like 50% or make it 40%. Okay, but how will it solve the problem? See, this was never a bottleneck. If this was never a bottleneck, why are you trying to solve it when there is no bottleneck here? See, take the example of a country, a densely populated country like India. Now, you see a lot of crowd on the road, and anywhere you go, there's a lot of crowd. Nowadays, it doesn't even matter if you are going to an expensive place because there's a crowd there as well. Okay, so if you know that population is your pain point, and you then say that we will build more temples, more mosques, or you say that we will educate people, that will not have an immediate impact. The first thing you have to do is create a rule. Anybody who produces more than two child or two babies will be penalized, a fine. They will not get tax credits. Okay, I'm not saying to jail them, I'm saying there will not be any tax credits for them. They will probably, your third child onwards may not land, cannot take a government job, or some sort of a penalty which will keep them away. and there should be some sort of monetary penalty immediately, so that that should persuade people from going in that direction. It's the same way. Now EC2 instances, it was never a bottleneck. Now if you give a solution around this, it will not work. Hence A is wrong. Let's move to the other option. So the second option says replace the ALB with a network load balancer. So again, one is type 4, the other is type 7. So this ALB, the problem was never here. ALB only routes the request to EC2 instances. So the read problem does not occur because of a load balancer. Okay. The load balancer, what sort of problem happens is if the load is too high, the request may get timeout. The problem doesn't talk about timeout here. It's talking about problem slowdown of read. So B will not work. Okay. Third one looks promising. It says add a read replica and direct the read traffic to the replica. So what it's trying to do is it will create a clone of this RDS. This orange one is a clone. It's a read replica. Okay. So since the problem is with the reads, we are trying to solve the problem here. Like since India's population is the problem, we will have to control the population. So you have to control it at the birth level. You cannot control it when the people are growing old and tell them that, hey, you get educated. Education doesn't solve anything. It's just common sense which will solve the problem. So here also we are using common sense. We are how we are using common sense is, please note this. I'm again telling, please focus on this. We are isolating reads from writes. So this database now will only be used for writes, and this database will be isolated, which will be only be used for reads. This is a read replica. Okay, this way all the read requests that comes from this place to EC2 will be routed here. All the write requests, that means if this user is updating a request, for example this is amazon.com and the user buys a product, he places an order. The order placement will go via ALB, via EC2 to this RDS. It will create an order, it will write an order. But when this user is trying to access data of what this user bought in the past, it will go to ALB, it will go to EC2, but then it will go to RDS. It will go here, orange one, because here it will read whatever past transactions the user has done, and this will flow back. So this option looks perfect, but let's still look at option D. So what this guy is saying is use a multi-AZ support. So suppose you have three data centers, three AZs. You put RDS, this RDS, you put it on three AZs. So this will be put on three data centers. How will it solve the problem? And saying you direct the read traffic to the new EC2 instance. See, when you are setting this up in an auto scaling group, EC2 is an auto scaling group, and when you are saying your CPU utilization thresholds are never crossed, it will never create a new EC2 instance. See, auto scaling, how it works, you start with two EC2 instances, and you say that if the threshold of 70% CPU utilization is crossed, you create a new EC2 instance. It's just like your team. Like you started with two team members, you're developing a web application, you started with a two team member, and then your project manager says if the load on these two team members increases, I will add a third team member similar to that. But what is the condition? If the load increases. Okay, but here it is saying the load never increased. So why will you like EC2 will never the auto scaling will never create a new EC2 instance, hence D will not work. So this is the right answer. We'll move forward. Let's see the next one. It's a beautiful rainy morning today. Now please pause this video, read this carefully, mark your keywords, and then you can hit play, because I'm going to mark my keywords. So here's a question. You have an app and the database is DynamoDB, and you have a problem. The problem statement here is you want lowest latency for reads. Okay, I marked this in bold because whenever I see reads and whenever I see latency, thumb rule. Reads and latency. What is the thumb rule? Anybody can recollect? Whenever you see reads and you want lowest latency, always use cache. Always use cache. Always use cache. And when you are having DynamoDB, that means your application, you're reading from DynamoDB. Okay, the reads are happening from DynamoDB. So when it is DynamoDB, what is the cache you use? You always use DAX. DAX is the cache for DynamoDB. For other database, memcache, elastic cache can be used for other database like RDS, RDBMS, etc. DynamoDB is a NoSQL database. DynamoDB is a NoSQL database. It's a NoSQL database. It is not a RDBMS. The caching for DynamoDB is always provided by DAX. That is DynamoDB Accelerator DAX. Caching for DynamoDB is not provided. Is not provided by Elastic Cache or Memcache, etc. Okay. Since you do not have to provide any changes, like very minimal application changes, I would plug DAX. So this is how it will look like. Between the app, mobile app, and the DynamoDB, there will be a DAX. Since the question says reads should be fast, lowest latency, reads means uh, you can read from DAX. So the app will read from DAX and will provide uh, the lowest latency. If there is no DAX and if it is always going to database, there will be some processing done at the database level and the data will be returned to the mobile app. That's why latency will not be low. But if you put DAX, it will straight away hit DAX. Data is in the ready format in DAX. It will go up, and that's how you will save on the cost as well and provide highest latency. So for me, A is the option, but let's look at other options. B says you add DynamoDB read replicas to handle increase read upload, upgrade the application to the point read. Okay, so it is talking about a read replica that we saw in the previous question. No? So it is saying you create a read replica. So it is saying is you create a read replica. This is a read replica, and tell this app, if there is a read happening, you go here. If there is a write happening, you go here. So what are you doing when you do this? The question, what did the question says? You want to do minimal changes. Did you do minimal changes? Now you're going all the way to create a database. Now you're putting some logic to sync up these two databases, because this read replica will be always out of sync. So you will have to always create a sync up between this database and this database, because this database is always having new data. Then you have to sync up the new data here. Are you doing minimal changes to the application? No. Compared to DAX, you are doing way too many changes. So C, B is wrong. Let's move to option C. So there are read capacity units in the DynamoDB. What it's saying is you increase the RCUs. Okay. So see, increase the RCUs. So basically what you're doing is you're still sending the request to the DynamoDB database. Okay. And then DynamoDB, even if you increase the RCU, it will do some processing. It will do blah, 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 get the data from here, get the data from there. And then it will return it. It is still not as efficient as DAX. Okay, it is still not as efficient as DAX. Okay, plus what's happening is you will have to, this will obviously increase the cost. Even adding DAX might increase the cost. So from a cost perspective, it is same, but it is not solving your problem. You are still sending the data or sending the request to the database and then telling it to process it, and you're telling that it's like, you have a team lead and you're telling that, hey, you know what, I'll increase your memory capacity. You give them some memory tablets and tell it for a month, and we will increase your memory capacity so that you can do more work. That's not a better option, right? So what's the better option? The team lead is doing some of the monotonous work, or like it is creating some standard Excel sheets, and for which you do not require a lot of brains. So you put a lower band resource or lower grade resource, a lower level resource, and maybe a college graduate hire. Okay, and then let him or her do that work. So what you are doing is you are increasing the capacity. You are increasing the latency, because all the lower work, Excel creation, PowerPoint, etc., will go to this resource, and you can still meet the deadlines. So DAX is similar to that. DAX will provide you caching. Option C is not better than option A. So This is wrong. Thumb rule wrong. With DynamoDB, you never use elastic cache. With DynamoDB, you never use elastic cache. With DynamoDB, you always use tags. Okay, so D is wrong. I'm not even going to explain it. So this is the right answer. We will move forward. The last question for this part, we will look at some more questions in the next part. Please pause your video here. Mark your keywords. So what is the technique we always use? You mark your keywords, understand the pain points, go through each and every option, and weigh each and every option which is better. Always think from lower cost perspective, even if the question doesn't say that, but your question should always be from a cheaper cost perspective, and it should meet the requirements. That's the thumb rule. So you pause this video here, mark your keywords. We will be back. So in simplest forms, what this question is saying, you have an application, okay, and then you create a backup of that application and you keep it in a warm mode, so that whenever you want to switch to that application, the switch will be fast. You will, because that application is already in the initialized and warm state, so it can directly switch. Now what the question says is, you don't need to automate the failover process. Okay, you have two instances, one in one region, the other in another region, and you want to automate the failover process, simple failover process, and there is load balancer, etc. So load balancer health check will not help you with failover. I explained you in the previous question in this part. LB health check is just to check if the EC2 instance behind it is in good state or not, otherwise it will shut it and it will always route to the different EC2 instances. This is not used for failover to a different instance or a different instance in another region. Okay, A is wrong. So this is correct. Whenever we have such kind of routing mechanism for failover, always thumb rule, route 53 health check. Always remember, this is a thumb rule. I'm repeating, this is a thumb rule 3 times. Keep it in your mind. This is a thumb rule. Whenever you see failover across 2 regions, across 2 AZs, route 53. This health check will check if your current application is in good state. Not, it will route to the other application, and the other instance is already in warm standby mode, so the routing will be faster. B is correct. See, CNAME is alias. This will not solve the problem, because what it is telling is you use alias on route 53 and you still point to the LB endpoint, which is a load balancer endpoint. So this will not work, because this is not a problem with allies. The failover, see, allies we use if we know that if suppose you have 2 instances, and if a read request comes, you put it to this instance. If a write request comes, you divert it to that instance. But here you have to take care of failover. For failover, always remember, it's some to health check. Failover, you have to use route 53 health check. Okay, so C is wrong. See, again, this is saying use conditional forwarding rules. Okay, so what it will do is, based on a certain condition, like if there are users accessing from certain region, then you forward it to this DNS. If it is coming from North America, you forward to this DNS. This is conditional forwarding. Here is not a problem of conditional forwarding. Okay, it is not like, if you have chicken biryani, then John likes chicken biryani. If you have chicken stew, then Smith likes chicken stew. It's not like that. It's like there is no food available. So whenever there is no food available, by default you switch to bread and butter. Is that kind of scenario. You are not getting options like you go in a hotel and a menu. If this happens, then I'll eat this. If this happens, then I'll eat this. There is no such kind of thing. It is failover. Failover means there is no food. And since there is no food, what is the backup option? Backup option is bread and butter is there. Like it happens usually at night, right? Certainly you get a hunger pang at 12 o'clock and you look out for apples, dry fruits, and so on. So it's similar kind of scenario. So D will not work here. So this is the right answer. This brings us to the end of this video. Please subscribe to my channel. I'll put some more contents related to Solution Architect Associate exam. Please stay tuned. If you have any positive feedback or any comment that I should improve, please let me know in the comment drop box. See you in the next part.